Hi everyone. Today's the third lecture for distribution protection. In past years where we've been able to meet in person, this has kind of been a lab. But today, or this year, everything is online, so a little bit different. I still wanted to give you guys an opportunity to see some of the equipment, see some of the hands-on aspects of this, as opposed to just listening to me talk in a lecture. I'm sure some of you are redistributing that as sleep aid material commercially. So, I'd like, unfortunately, can't all be here in person today, but I've got Jude to help record, and we'll go over some of the equipment in the lab. Check the class folder there. You guys should have a wiring diagram for the rack here, with some schematics to see how everything's wired. And then you should also have a relay logic diagram that I put together that we'll be walking through today. It will be really the premise of this lab is to walk through the logic diagram. So here in the rack, we've got an SCL 421. This is primarily the relay that we'll be working with. The 421 is a line protection relay. You can see here, the 4 is just a 400 series. 21 stands for distance protection. That's kind of its specialty, is distance protection and protection schemes. They use distance protection. Below it, we won't be using this today, but it's awesome you guys have one. We've got a bus protection relay, a 487B. Moving down from there, we've got some control switches. You can work through the elementary diagrams, but this selector switch right here will toggle you between the controls being utilized for the different relays, the 451, the 421, and the 487. Today we'll be on the 421. That's the relay that I have set up. This right here is a lockout. It's generally used to trip and then protect devices from being energized on until someone manually resets the lockout. This lab actually cleverly repurposes the lockout, almost as like a breaker simulator. We don't have a breaker in the lab. Breakers are as big as minivans. But this is this with an electric trip, an electric reset, is a pretty good simulation. It actually makes a pretty decent bang here in the lab. So it's, like I said, pretty cleverly repurposed. And right here is a breaker control switch. It's used to trip and close the breaker, and then has little light bulbs here for the status of the breaker. I briefly touched on it. We've got a 451 down there that's usually used as a breaker control relay, or breaker monitor relay, breaker failure relay. We'll just say breaker relay. And then at the very bottom, we've just got the power supply. I gotta turn that on to have power. Everything here actually does have Ethernet communications. If you wanted to tie the network switch, which I think has fallen, you could. But yeah. All right. So we can see up here on the 421, it's got configure labels. You can slide these labels up under here and give you an indication of what these LEDs mean. I have configured these labels, so hopefully these are pretty accurate. They are associated with, on your logic diagram, the LEDs on your pictures. So this will give you a visual aid as to what's going on, as well as the logic diagram. And I hope, as we go through this video, you guys have the logic diagram open, are following through it with me, because without that, everything I'm saying is not going to make a whole lot of sense. So we'll walk through this logic. So the first part of the logic is the 52 control switch enabled. This particular relay is set up. You can actually trip and close the, we'll just say the breaker because it's easier to say breaker, through the push buttons on the relay, or if you've enabled the 52 control switch enabled, you'll use the control switch down here. It's a rough let's say simulation maybe between, I know these are both local, but what could be, you know, a local control and maybe a SCADA control or an HMI control or something along the lines of that to be able to switch back and forth. So logic is fairly simple. If you hold the button for a second, the 52 control switch logic will be enabled. If you hold it again for a second, it will be disabled. You can see that there on the first sheet of logic. You can see we've got a 1 second timer for that push button. If you just bump it, it ain't gonna do nothing. It's gotta get through that full second. You really gotta mean it to turn it on. So that's the on and off for that particular push button. Next, we would go to the test mode on and off. This relay is set up with a few test functions, like a test trip, a test breaker failure trip. But in order to use those functions, we want to be in test mode. I gave it a test mode to easily test these things as opposed to really testing them, which would require, you know, hooking this up to a test set, you know, injecting currents. A lot of really great real world stuff that we just don't have time to do right now. So we can see here, that's going to be push button 4. It's in the middle of sheet 1. That's actually attached to what's called a flasher. So when I turn test mode on, this LED should flash. And again, I can turn it off. So that's almost identical to the control switch logic. It's just a mode that we're turning on and off. The last mode on the first sheet is breaker hold. Breaker hold is a way to ensure that the breaker is not going to open or close. It can be used as a tagging function to make sure that people working around the breaker can feel safe that it's not going to operate both electrically and mechanically. You know, that they can feel safe. So same way, we can turn that function on and off. Ignore that, we drove the reclosing to lockout, and we'll get to that later. Oh yeah, and we drove 79 off. Okay. We'll follow that logic out and see why that happened here in a second. So that was the first sheet of the logic. There's really just a bunch of enables or modes that we turn on and off. We've got a second sheet of logic here. This is really tripping logic. We can work our way through a lot of this, but not all of it, because a lot of these protection functions require voltages and currents that you might see in the real world, but that we would need to hook a test set up to have work. What we can run through here, though, is our manual tripping and our test tripping. So we can see right now, based on this LED, that the breaker is closed. We can also see it down here that the breaker is closed. Well, if I come here and I hit the open button, I can open it. If I want to, I can close that breaker back in. So those are our manual, you know, open and close or trip commands that we have here. And that's doing it through the push button. We can see if I come down here to the breaker control switch, it's not doing anything for us. But that's where that 52 control enabled command comes in. If I want to put it on the 52 control mode, well now, push button doesn't do anything. But I can come down here and open and close the breaker through the breaker control switch. I can turn this mode off to get it back into its, you know, its normal mode, which, you know, would be through the relay push buttons. So we just worked through, you know, the manual. Oh, forgot the hold. Yeah, with the hold, neither one will work, right? We've ensured the people on site that the breaker is not going to open or close. It doesn't matter if we do it through the push buttons or if we do it through the breaker control switch. You know, that hold function has made the people, you know, on site, you know, be assured that the breaker is not going to operate. We'll turn that off. That drives reclosing off. We can reset that. That pushed us into a 79 lockout. That'll reset on its own. But what we've now done is we've worked our way through this manual trip logic right here. Everything on this part of the logic diagram. We've also been able to watch the LEDs on the front of the relay assert, and then also the the light is driven by a relay output down here. So these lights down here are actually being driven by the relay as well. So those were manual trips. If we want to, we can do a test trip. So if we go to sheet 3, where's my test mode? I think it's on sheet 4. Yeah, test trip is on sheet 4. If we want to, we can put it in our test mode, which we've confirmed, the function works from our first sheet of logic. And then if we follow this logic out, we can actually see a test trip with push button 3. If the relay is in test mode and we hit a test trip, this variable right here will assert and then go to our trip logic on sheet 2. It'll come right here through our OR gate and go to our trip equation, which will trip the breaker. So I can come in here. Just because I don't want it to do it right now, I am going to turn reclosing off. But we'll run a test trip. And we've tripped the breaker. That was a test trip of a protection trip. We can see up here the trip LED has asserted, which wouldn't happen for a manual open. It would just happen for a test trip. But what we can do now, if we want to, is turn test mode off. We can close the breaker. We won't hit the target reset to clear the trip that happened. Okay, turn 79 back on. And that's something called a reclaim time. After a period of time, after a reclose initiates, it'll go away. So we've worked our way through most of the manual trips and through the protection trips, which is essentially what we're doing on sheet 2. Sheet 3 is reclosing. I think I may save reclosing for last. There's a little bit going on there. And we can move to breaker failure, which kind of aligns with what we've already been going over. So breaker failure logic. What we've got here set up is a conventional breaker failure, and what's called a no current breaker failure. We don't use no current breaker failure very much, but it is super convenient for test trips because we don't need a test set wired up, which we would need for a conventional breaker failure. So similar to push button 3, which was a push button test trip, we have a breaker failure test trip as well. And really all the breaker failure test trip does is it does a test trip, but it blocks the output contact of the relay from tripping the breaker. So the relay says, hey, we issued a trip, but it never tripped. The breaker must have failed. It's a quick and dirty test, a way to test this, but it works well for this situation. So we can see that, right? If we issue a breaker failure trip, it'll go to the trip logic on sheet 2. We can see here that the test breaker failure trip hits the protection trip logic, but then it actually loops back around right here, and for 60 cycles or 1 second, it's going to block that output from tripping the breaker. Well, that breaker is supposed to close in 3 cycles, and it's not going to because of this logic, right? We told it to trip, it didn't trip. it's a breaker failure condition. So we can walk through that situation. So we did what we did before. We put it in test mode. We put it, and we're gonna run a test breaker failure trip. Okay, so the breaker did eventually open, but it was too slow. We can see here we drove reclosing to lockout. It's not allowed to reclose, that makes sense. And then we have this breaker failure trip condition here. One extra thing about the breaker failure is you actually won't be allowed to close the breaker until someone has actually investigated that breaker failure trip and reset it, right? If we try and close, oh shoot, I must not have looped that back around. There, let's check the logic. We may need to make a tweak to this. Let's see here. Breaker failure trip, it hits the breaker failure latch. Yep, that breaker failure latch never goes back around to the close logic. Usually we don't want to close for, but we want to block closing for a breaker failure trip. So I'm going to edit that for next year and have this part of the logic loop back around into the close string. Probably be a good thing to do. But we'll hit the target reset to reset those LEDs. So that's the breaker failure logic, I guess, in a nutshell. The last thing that I did want to go over was the reclosing logic. That's on sheet 3. We do have I'll turn test mode off. Breaker is closed. We do have a 79 on off. If 79 is off, we can't do any reclosing. If 79 is on, then we're permitted to the reclosing. Also, the breaker failure trip will drive the reclosing to lockout. So it would block the reclosing. I need to put it here into the breaker manual string to prevent it. Like I said, I'll do that next year. So we can see here, even though we've already worked through a lot of it, we do have the close logic, the manual close logic on this sheet. I'm not gonna run through the push buttons on that again, but we can see, push button 7 can be used for the manual close from the relay, as well as the breaker control switch, depending on the status of the control switch control, or the hold. None of that's gonna happen if it's in hold. But I've got this reclosing logic set up so that if I put it into test mode and run a test trip, it will send a reclose initiate to the reclosing logic, and the breaker will actually automatically reclose. Now we can either allow it to reclose and stay reclosed as if it was a temporary fault, or we can just hit the test trip again like it was a permanent fault. So I think what we're gonna do is walk through an entire reclosing sequence and watch that play out. So if I come here, I'm gonna hit the test trip. It's gonna have an open interval. I can't remember how long my open intervals were. They were in the range of 10 to 15 seconds. I'd probably shorten it for next time because it is gonna push our patience. But we'll see it reclose. Plenty of time for the squirrel to burn and fall to the ground. So all right, we'll give it a test trip. Okay, so we can see the breaker opened. Reclosing is not off. Oh, it reclosed. Let's give it another test trip. We're gonna have a longer reclosing time this time. Give it, an even longer open interval. And give it another test trip. They should have one more reclose, I think. This is a long one. And one more test trip. Okay, and we can see here, that's as many chances as we're gonna give it. The breaker is now open. it's not going to reclose. We can see that our reclosing failed, and is no longer going to work. If we want to, we can manually close this, and we'll actually find this has got something called a reclaim time. It's not going to allow you to reclose if you just made a manual close. So if we re-trip, it shouldn't reclose now, because we only want to we only want to reclose based off those protection trips, the line trips on the overhead lines that are temporary in nature. We don't want it to be on a manual trip because most of the time for manual trips, people are on site. It's usually dangerous. But I can hit the target reset, get rid of that trip indication. This LED is actually based on time. That'll go away on its own. I can turn test mode off and close the breaker. And we're kind of back to a normal situation. So that's the majority of the logic diagram. That can be simulated with the push buttons. There's definitely more that could be done here, but it would require a test set, which I would think would be fantastic if we had time to do. If someone who was proficient using a test set came in and got everything wired up, and developed a test plan, and went over that with you guys. But this is generally what I wanted to go through. So appreciate the time, and see you guys later. Thanks.